This video is on section 3.5 notes, pyramids and frustums of pyramids. So a pyramid is a solid object or a 3D object with only one base and three or more lateral faces that taper to a single point opposite the base. So we knew that prisms before had two bases that were parallel, so they kind of went up and down. So these are going to be pyramids if they taper in, and you can see we've got a base down here and then it tapers. Just like before with the prisms, a pyramid is named based on its base. Next, we have the apex, which is the single point opposite the base. So here's the base down here, there's the apex. Opposite the base of the pyramid, which the lateral faces taper to. The altitude, again, is the perpendicular distance from the apex to the base, also known as the height. And then the slant height is the height of one of the lateral faces. So we have the height where you could measure it from the middle of the base up to the apex, and that would just be the height overall, like how tall the prism is. But then if you measure how tall each of the sides are, you're measuring that at an angle, and so that would be the slanted height. So two different things, and we'll use them in different contexts. So it's important to know the difference between them. Altitude, regular height, slant height. All right, so this example right here, the base had 1, 2, 3, 4, 5 sides. So this would be a pentagonal pyramid. Here we have a square pyramid. Because this is a square pyramid, that means the lateral faces are isosceles triangles. The two sides would be the same length. We have a triangular pyramid. The base is an equilateral triangle, and then the lateral faces are isosceles triangles. And of course, we could have all other types of pyramids as well. So with pyramids, we have some formulas just like we had before with prisms. So again, we're going to find L, T, and V, where we have the lateral surface area, the total surface area, and the volume. The lateral surface area is 1/2 times P times S, where P is the perimeter of the base and S is the slant height of the lateral face. The total surface area is 1/2 times the perimeter times the slant height, and so this is the lateral surface area plus the area of the base. And then the volume is 1/3 times the area of the base times the height. All right, so for the first example, it says the square pyramid shown has a slant height of 10.77 feet and an altitude of 10 feet. To find the lateral surface area, first calculate the perimeter P of the base. So first we're going to go through and we're going to say the lateral surface area is 1/2 times the perimeter of the base times the slant height. And so for the base, we have a square, and so the perimeter of the base is just 8 plus 8 plus 8 plus 8, and 8 times 4 is 32. So the lateral surface area is going to be 1/2 times 32 times the slant height, which is 10.77. It would help if I had a calculator that wasn't dead. So 172.32. This is lateral surface area, and so we're going to have our units, which are feet, squared. And then next we're going to go ahead and find the volume. The volume is 1/3 times the area of the base times the altitude of the entire pyramid. And so we can go ahead and find the area of the base. I haven't found that yet. The area of the base would be 8 times 8, which is 64. So this would be 64 times the overall altitude of the pyramid, which is 10. So 1/3 times 64 times 10, 213.3, repeating, feet cubed. So here, for each of these, I rounded to 2 decimal places or the nearest hundredth. The way you're going to round is going to depend on the instructions for the problem. So whatever they tell you to round to, that's what you're going to do, whether it be significant figures or to a certain decimal place. Here it says find the lateral surface area and volume of this triangular pyramid. Remember, the base is an equilateral triangle. Okay, so the lateral surface area is 1/2 times the perimeter of the base times the slant height. So we have 1/2. The base, they measured right here that one side of the base is 16, so this side would also be 16 centimeters, and then the back side right here would also be 16 centimeters. And so the perimeter of the base is 16 plus 16 plus 16, 3 sides. And then the slant height, we can see that the slant height is right here. This dotted line is how tall the lateral face is, and then the overall altitude is written right here. So slant height is 36.3. Your slant height, because it's at a diagonal and not straight up and down, it's always going to be a little bit more than the altitude. All right, so 1/2 times 16 plus 16 plus 16 times 36.3 is 871.2 centimeters squared, because we're talking about surface area. Area is always square units. The volume is 1/3 times the area of the base times the height. So 1/3 times the area of the base. Now this is an equilateral triangle, and the area of equilateral triangles is 0.433 times the side squared. That's a formula that we learned in a previous section. So I'm going to say 0.433 times 16 squared. So we have not 1/2. 1/3, excuse me. 1/3 times the area of the base times the altitude, 36. So 1/3, make sure you notice that I had a typo. 1/2 I had written at first. It should be 1/3 times the area of the base. This is our formula for area of an equilateral triangle. Area of the base times the altitude. So I've got 1/3 times 0.433 times 16 squared times 36. And this is 1,330.176 centimeters cubed, because we're talking about a volume. Okay. All right, next we have an example of kind of a word problem again. So it says, one section of the roof of a building is in the shape of a square pyramid with a side length of 28 feet and a slant height of 13.25 feet. A heat reflecting paint with a spreading rate of 150 square feet per gallon is to be applied to this section. Suppose we wish to know the number of gallons needed in order to apply 2 coats of paint. So putting paint down, they were talking about square feet. They're applying paint to a section. So it sounds like we're looking for a surface area of something. And then we have to think through our formulas. Would it make more sense to do lateral surface area or total surface area? If we're talking about a pyramid shape and we're doing the roof, then we're just going to do the lateral surface area. So we just want the the side triangles, it's even a square base. So it's gonna, the building looks like this. We don't want to do the square on the bottom because that's not the roof. That would be like the ceiling inside the house. The roof is going to be the lateral faces. So we're going to want the lateral surface area. So I'm going to write that formula down. The lateral surface area is 1/2 times the perimeter of the base times the slant height. Okay, so it says one section of the roof is in the shape of a square. The square has a side length of 28. So square side length is 28. So if I want to find the perimeter of the square, then I just have to do 28 for 4 sides. All right, so we've got the perimeter, 112. And a slant height, and they just give us the slant height, is 13.25 feet. So the lateral surface area is 1/2 times the perimeter times the slant height, 13.25. And I'm going to multiply all those together. 1/2 times 112 times 13.25, excuse me. 742. So the lateral surface area is 742 square feet. And then they said if this is how much we know we're painting, then the amount of paint we're doing is 150 square feet per gallon. And we're applying 2 coats. So I'm going to take 742 square feet and convert it into gallons. So it was 150 square feet per 1 gallon. 150 square feet per 1 gallon. And when I do this conversion, this is going to tell me 1 coat, and I'm going to need to double it to get 2 coats. So 742 divided by 150. Okay, so it's approximately 4.947 gallons for 1 coat. I'm going to double that times 2. That's approximately 9.893 gallons for 2 coats. So when we talk about gallons of paint, if I was to buy 9 gallons, then I'd be a little bit short. Well, a bit short. So I want to buy more than enough paint so that I can paint the roof and have a little bit left over. So I need to buy 10 gallons of paint. So buy 10 gallons. In word problems, you always have to think about your answer within the context and what makes sense. And so here, the decimal answer wouldn't make sense because no one gets to buy 9.893 gallons of paint. Everybody has to buy whole number gallons or maybe half gallon or something like that. But this amount of precision of paint is just not going to happen. And also, you might drip some on the ground or whatever. So definitely going to have to buy a full amount, buy 10 gallons. All right. Next, we're going to look at a frustum of a pyramid. I have no idea if I'm saying that correctly, so if you want to look it up on Google and then correct me, that's fine. A frustum, also known as a truncated pyramid, is the solid figure remaining after the top of the pyramid is cut off parallel to the base. So you leave this little pyramid up here that is proportional to the overall pyramid. It's just a similar figure that's smaller than the original pyramid was, but you have 2 bases now, the top base and the bottom base, and they're parallel and they're the same shape but different sizes. So most frustums used in practical work are of square pyramids or cones. Every frustum has 2 bases, upper and lower, that are parallel and different in size. The altitude is the perpendicular distance between the bases. So again, the altitude is the height. All right, so we have a couple different formulas. We have the lateral surface area and the volume. Over here we have the labels, so you can see that we have A sub 1 and P sub 1, which represent the area and perimeter of the top base, or the upper base, and then A sub 2 and P sub 2, which are the area and the perimeter of the lower base. So we're going to find L and V, the lateral surface area and the volume for the frustum. And first, I'm going to go ahead and find the area and perimeter of the upper base and the lower base. So area, perimeter of the upper base, area, perimeter of the lower base. So the area of the upper base is 9 times 9, which is 81. The perimeter of the upper base is 9 plus 9 plus 9 plus 9. That's 9 times 4, which is 36. The area of the lower base is 15 times 15, which is 225. The perimeter of the lower base is 15 plus 15 plus 15 plus 15, which is 60. Okay, and then we have our other measurements we're going to use. Our slant height is 5, so that's this dotted line right here. This is 5, and then the altitude is 4. So the lateral surface area is 1/2, and then the sum of the upper and lower base perimeters times the slant height. Okay, so I've got 1/2. The sum of the upper and lower base perimeters, P sub 1 plus P sub 2, is 36 plus 60. The slant height is 5. 1/2, 36 plus 60 times a slant height of 5 is 240 inches squared, because this is a surface area. And then the volume is going to be 1/3 times the altitude. And then we've got the sum of the areas of the upper and lower base plus the square root of the product of the upper and lower base. And I'm not going to write that out in words because that's just a lot of words and I don't feel like doing it, to be honest. Okay, so 1/3 times the altitude, which is 4, times the upper and lower base areas added together, so 81 plus 225, plus the square root of the product of the upper and lower bases, so the product of 81 and 225. Okay, so we have 1/3 times 4 times 81 plus 225 plus the square root, and the square root is right here above the x squared button, and it's in blue, so I'm going to hit blue second. All right, 81 times 225. So this equals 588. Inches, yep, inches cubed for volume.